Welcome back, everybody. So this video is all about measures of position. In our last video, we talked about measures of spread. And so what we have here is a quick little formula sheet for those measures of spread. There was one point I wanted to bring out from the previous video. That is, look at the difference between the population variance and the sample variance. The population variance is divided by n, the sum of squares divided by n. The sample variance is divided by n minus 1. Why is that? Well, because in the population, you have every single person in your study. That means there's no bias, because if you have everybody has a chance to vote and make their decision, which means we could divide by n. But when you take a sample, you bring in bias just naturally. You don't have everybody. That means there's at least one person you did not talk to and you did not get their data, which means even though the bias might be small, there is bias in your data. And that's why the n minus 1. There is big reasons, mathematical reasons, calculus reasons behind this. But my reasoning to you right now is all about the bias of the sample. All right. So please notice they are very, very similar formulas. Sum of squares divided by n, or n minus 1. You just got to know if you're dealing with a population, which is everybody, or a sample, a subset of that population. Excellent. Now, we're here to talk about the Z-score. The Z-score is a great way to talk about position. And so we go back to the data we had. And so in this data set, we are looking at treadmills. And we're trying to come up with, in this case, for TM 195, a kind of structure for which, what's a typical age for a person buying this treadmill? What would be a young age? What would be an average age to buy this treadmill? I mean, we got the average is 28.55, but an average age to me means a range around average, because you're not just going to always see somebody close to 28.55, but how close to 28.55 is a person, and they're still called quote unquote average? The answer comes in the position formula. So what we do and what we can do is insert a position formula called the Z-score. What is the Z-score? Well, we go back to our formula sheet, and you may pause here, take a picture of it, or send me an email. I'll be happy to send it to you. No big deal. So what we have is the Z-score is a measure for location. You need your mu, which is another word for average, and you need your sigma, another word for standard deviation. If you take your raw data value minus your average and divide by standard deviation, you get this location number called the Z-score. Lost where I'm going. Sorry. That's the original. There it is. All right, so here we are. So I want to come up with the Z-score for each of these numbers. How do I do that? Well, think about the formula. It is equals, in the numerator, you're taking each value and seeing how close they are to the average. Well, that makes sense. How close is each number to the average? And that's not written correct, so I need to start it over again. So my age minus, let's say I was 18, and I wanted to know how far I am from average. Well, you can do quick math and say, well, of course, that's your deviation, right? You are negative 10 points away from average. That's your deviation. That's great. But I want to offset it by the spread, because the spread factor tells me how far, the standard deviation tells me how far I spread from one person to another. So you see, the position and the standard deviation are very tightly linked. I mean, to find the Z-score, you need to ratio or divide by the standard deviation. The standard deviation in this example for the TM 195 is 7.22. Of course, yes, I went up to there. I know it's down here also. I could have gone to either place. If you're wondering what this is, please watch my previous video on the measures of center and position. This is called the descriptive box. It's a great box of information. It gives me the mean and the standard deviation. From there, I can find a position of anybody, their Z-score. So what is the Z-score? It's a measure of position. What do I mean by that? Well, the way I look at it is I like to have a nice little picture. I like to have my Z-score and the X, which I call the real world. you see there are some common z-scores: -3, -2, -1, 0, 1, 2, 3. There's some common z-scores we always talk about. A z-score of 0 means you're perfectly average. So that would be the mean. You'd perfectly average the mean. So if somebody got a z-score of 0, that means their score, their age was 28.55. This is a great measurement of position, how close you are to average. Now, what are the units on the z-score? There are none. Think about that for a minute. There are no units on the z-score. How can that be? Well, let's check this out. The formula, once again, is my value minus the mean. So that would be age minus age. So that difference would be age difference. The denominator is the spread of age. So really, the numerator is in years. That's a 10-year difference. The spread is 7 years. If I have 10 years over 7 years, the years cancel, and we're left with just a number. That's the great thing about the z-score. There are no units on the z-score. Now, notice I got a negative z-score. You want to know what that means to me? That means to me that we are, there we go. That means we are way under average. I'm just trying to make it a little bit bigger or smaller. It's kind of tough, but this seems good enough. So that's the z-score of 18. Once I've written the formula right, I can copy it down. The problem is it's not correct yet. I would pause the video, see if you can fix it, and then I'll move on. All right, we're back. So how do you fix this? Well, anytime in a formula you do not want a number to move, you would absolute reference its cell. To absolute reference a cell, you put $signs around the letter. So M10 is the average. I don't want that to move. R1 is the standard deviation. I don't want that to change. I don't want those numbers to change as I go down. I do want B2 to change to B3 and so on as I move down. Now that it's written, I can double click and watch the rest of the column populate. Now I love doing this right away because what I look for is who in my data set is really represents almost perfectly average. And that would be the age of 29. Look at them. They are 0.06 units above average. That makes sense because average is 28.55. They are ridiculously close to average. 28 and 29. 29 is just above average. How do I know? Because it's a positive z-score. 28 is just below average because it's damn close to 0. Excuse my language. Really close to 0, but just underneath. All a negative represents is below average. It's okay to have a negative z-score. Heck, in the age range, I want a negative z-score. I want to be younger. Maybe not too young, but younger. All right. The positive z-score, as you go up the scale, the positive z-score gives you, all right, how far you are away from average, but how much above average you are. 50 is almost 3 units above average, 3 z-scores above average. What does that mean? Well, that's what the rest of this video is about. Now that we know how to build the z-score or find the z-score, we should explain what the heck does it mean. Well, first, let's find a few more z-scores. For example, let's say the z-score is 1. How would you find the age for that z-score, especially if it's not in the chart? If 1 is not in the chart, as you look down, 1 is not exactly in the chart, it's 103. So what would be the exact age of a z-score of 1? I'm going to pause. I want to see if you can figure that out. All right, we're back again. From now on, then, I'll pause to see if I give you a chance for you to pause the video and think about that. A z-score of 1. How can I find the x value? The answer is, once again, in the formula. If I know the z, and I definitely know mu and sigma because they were given in the descriptive box, I can solve for x. So if I know z is 1, and I know sigma, I'm going to cross multiply 1 times sigma, and then add the mu. It's called good old algebra. So here's z. I'm going to cross multiply the sigma and add the mu. And that's how I'm going to get my number. So I'm going to take my z, multiply it by sigma, standard deviation, and add on the average according to the formula. Boom. And there it is. That is my z my perfect real world number for a Z of 1. It would be 35.77 years old. The units here are years because we're looking at age, if that wasn't clear before. All right, how would one find 2? Well, we'd use the formula again. Now it'd be 2 equals. So the formula would mean I'd take 2, multiply by the standard deviation. Think about this. We're taking 2 times the standard deviation. The 2, get it? The 2 times the standard deviation. We're adding on the center, the mean. So you can think of 2 as the barrier between if you are 2 points above the average or 2 points below the average, points being standard deviation points. So the spread here, 7.22, or down here, 7.22, is very important. This is the typical spread per person when they walk into my store. The typical age gap for a customer that buys the TM195 is 7.22 years. So I know when I see the next customer and then the next customer, the average age difference is 7.22. That's what the standard deviation is a per person, in this case, difference, per age difference per customer. It's about 7.22 years. This will help me build these because that's what I'm utilizing. I'm utilizing the fact that a 3 means I am 3 standard deviations above the center, the average. And that's really what it represents here. A person that's 50.2 years old would be 3 standard deviations above average. That is, again, the average is 28.55. So I imagine here's the customer that's perfectly average. Another customer walks in, there are 3 standard deviations above my average person. And that's what the Z-score represents. How many standard deviation a person is above the average. If they are at a 3, there are 3 standard deviations above average. If they are 42, there are 2 standard deviations above average, the Z-score. Of course, somebody can be below average. How do you become below average? Well, instead of positive 1, it's a negative 1 times, a negative 1 times the spread factor, adding on the mean. I'm just working on this formula right here backwards. I put a negative 1 in here, multiply the sigma, add the mu. I want to find x, the real life number. Z is the position. What position is a negative 1 in? Well, multiply the sigma, add the mu, and we'll find your position like I'm doing. For a negative 2, I would multiply by the standard deviation, because that's the cross multiply, and add back the mu. And each one of these, when I build them, gives me an idea of my customer base. That's why I love drawing this silly little picture here, right here. This is kind of my customer base picture for the TM95. I know a typical customer falls between -1 and 1. This is perfectly average. But a typical customer age that I would expect to buy my 195 treadmill is between the ages of 21 and 35. That is my signature customer, my customer base. Can we expand that customer base? Well, time to talk to the marketing team. But at least I know my typical customer base. We'll learn later what it means to be typical. That is very important, okay? We're going to put probability to this later on in later videos. Look at my probability videos to see that, the normal videos to be exact. But right now, I can give you a range for a typical customer between 21 and 35 years of age. All right, a slightly, and I use my words briefly here, carefully, slightly below typical would be somebody that's in the age range of 14 to 21. That would be somebody slightly below typical to buy my treadmill. You're slightly below average if you're between 14 to 21. All right. If you're under the -2, as we call it, so above 14 in age, so 14.1 and above, you're in this roughly average range. This is really average. The -2 and 2 are really the bounds on average. It is when you get past the twos, you get to the exciting ages. So really, these are the barriers right there. Anybody below 14 buying my treadmill, I'm going to raise an eyebrow and go, whoa, what was that all about? I really would be shocked anybody younger than 14 buying a treadmill. So yeah, that's a shocker. Vice versa, anybody above 42.99, that's slightly unusual too. That would be what we call classic outlier. A classic outlier are numbers above 2 and below -2 for z-scores. All right, that's very important. Now, not only are there slightly outliers, we get into what I call the serious regions, the -3 and 3. Those are your true outliers. Those are the true outliers. Anybody that lives between -2 to -3 and -2 to 3, those are true outliers. Now, if you get past the threes, you're in the extreme outlier. If somebody walks in that's 6 years old and buys a treadmill, okay, that's some questions I have to think about. But here's the other thing. This is probably more practical. If anybody over 50 years old comes in and buys my treadmill, first of all, I'm shocked. Second of all, I'm very happy because I've extended myself into an area that is very unusual. The blue ones are very unusual for me to see. Anybody above a 50 is very unusual to see. Anybody below a 6 in age is very unusual to see. These Z values, again, remember how they came from. They came from the standard deviation, the spread. The standard deviation is a per person spread. They build this chart. I utilize this chart to understand my customers, understand my clients, understand what should happen. In the typical day, the average age will be between 21 and 35 years old. If they're under 14 or above 42, wow, that isn't unusual. If they're definitely below 6 or above 50, that's extreme outliers because of their Z values. So just to remind you, again, we created this Z value chart right here, the Z-score chart. What I can do now is I can go over here and say, in my data set, do I have any potential outliers? And so what I can do now is, knowing the fact that anybody above a 2 is potentially an outlier, look at this. We actually have 5 people that are potentially outliers buying this treadmill. So what could you do? Well, you could definitely ask them, so what did you come in for? What brought you in? Was it our sale? Was it good rapport? What got you here? Because we want to extend our customer base to all clients. On top of that, there's another thing you could do. Now that we have potential outliers, you might think about, maybe I need to cut them out of the data and rework everything. Rework the mean, median, mode, range, variance, and standard deviation. Rework all of this without the outliers. And then the best thing a reporter can do is report all the numbers like you see here with the outliers, and then report what it looks like without the outliers and compare them. That would be a true good report, is we found outliers. Why are they outliers? Because they're past this red number. Anybody whose Z value is above a 2 or below a -2 is an outlier. Anybody's Z value that's above a 3 or below a -3 is an extreme outlier. We don't have any negative, notice we don't have any negative outliers. There's not too many young people, 18 was young, but we did have some older people in. So the first thing I would do is focus on them and understand what brought them in to help me with my new client. Second thing, if we're talking about data and we're trying to report the average, maybe those 5 people that just came in because of a sale or a holiday rush are throwing off my data that I want to put into a brochure. So what do I need to do? I'd have to rerun the data, to be honest, without the outliers. How do you do that? Well, data. And I'm pausing, giving you a chance to try it. And we're back. Data analysis, descriptive statistics. Click OK. You want the numbers you want. We now know we want this restricted range in the age. We want this, yep, that's good to there. We don't want the outliers, and we want the ages. Do not scan in the Z's, okay? Scan in the ages. I want the statistics on the age. Where do I want to put it? I want to put this exactly here. Got to be very careful. Summary has to be checked. Again, you're going to use the descriptive box in Excel. Input properly. Make sure you know your data is collected by columns. Do not highlight labels. If you do, be careful. Make sure you put it in a spot where at least you know you have this much room. Summary. Boom. And so now this would be my TM195, no outliers. And to be honest, that is really cool what I have here between these two pieces. I have my TM195 for all my customers, 80, and then my non-outlying customers, the 75. And now I can compare and contrast. How much did my having taken out my outliers affected my mean? Look at that. It went down by just 1, so not much. Didn't affect the median at all. Didn't affect the mode at all. And I already talked about that, right? The median is not affected by outliers. The median is the middle number. But the mean was affected a little bit. Not much in this case. We got lucky. But still, which mean do you want to report? One with all the data or the one with the older people taken out? That is your choice as a researcher. You just got to be honest in what you did and who you collected. You might want to restrict yourself to say this data is for people within this age range. Notice other pieces of information. The range went down, makes sense. You get rid of the outliers, the range goes down. Notice the spread went down. It went down pretty good. It went down by 2 years per person, right? Right now, the more honest data would be the fact that the average age difference in my store is about 5 years, 5.77 years. It was slightly skewed because of the holiday rush, and we had some older people here grabbing the sale, and that's why it went up a little bit. Again, how was I able to rebuild this? It's because, bottom line, the standard deviation leads me to the Z-score. The standard deviation is a spread per person. Knowing typically what the average age difference is per customer is very important to me. This will decide what is an unusually young or an unusually old person that will buy this product, the TM195 that we're studying right now. A typical customer, again, this is with all the data points, is between those. We'd have to rebuild this table without the outliers to see what it looks like when you don't have the outliers. What other things do I want to mention? Well, there's 3 more numbers in here, right, that I haven't highlighted from my previous video. I'm not worried about the standard error. That comes later. Don't care about it. I'm not worried about kurtosis. Not a big deal. Skewness, I do like. See, people often ask me, how do you know if you have a normal data set or a symmetric data set? The skewness is one thing I use. There's a few things I use. First, I draw the box plot. Second, I draw the normal picture. I draw the histogram, and I see if it looks normal. In future videos, we're going to be doing this as we check out normality. So check out my video on normality. I'll build a box plot to see what the data set looks like if it's roughly symmetric. I'll draw the histogram to see if the data, again, set looks roughly symmetric with a very particular pattern for normal. I also can look at it quantitatively. If the mean and median are roughly the same, that means the data is not too skewed in one direction. In this case, 28, 55, and 26, that's not too far off in age. That is why the skewness was not that much. So what is not that much? Well, that's a good question. I like to use the 0.5 as whether I'm skewed too much for my likeness. So this is above 0.5. And 0.5 means when it's a positive skew, I'm skewed positive, which again, we knew that. We had some outliers pulling my tail up. So if I built the box plot for this, which can be done easily, highlight the age. The great thing about the new Excel, right? You can add all of these things back in quickly. There's my box plot. Boom. And so my box plot is skewed. What I mean by that is look at the longer tail here in the outlier. Look at the longer tail. If it was symmetric, these would be roughly the same. Remember, if you want numbers, you would just add data labels. Click data labels on chart elements. And you can see it now. These are 14 apart. These are 5 apart. There's clearly almost a triple difference here between this is min to first quartile and third quartile to max. There is a tripling of distance. That's where the skewness is coming from. All right, and you can also see this in the histogram. There's clearly a skewness in my data set. That's going to throw off probabilities I do later on. I'd want a more normal data set so I could apply probability theory to it. Again, look at later videos on normality and probability to see how I deal with that. It probably would be with this data set right here. This is closer to the 0.5, and the mean and median are closer. So I'd probably look at the box plot of this because the mean and median are close. The skewness is close to my 0.5 range. So my box plot should look pretty symmetric, pretty normal. And so I'd probably do my data analysis without the outliers because of that. Again, outliers are really throwing off my chances to move on and talk about normality and what to do with that. But those are meant for later videos. In this video, it was all about understanding what the standard deviation does. The standard deviation is a difference per person. In this case, difference per customer and age that buys this. So again, if we go to the original data, just to summarize it one more time, when I see 2 customers in the store, their average age, if they're buying the TM195, the average difference between them is 7.22 years. Knowing the standard deviation allows me to build the position box, known as the Z-scores. You find the Z-scores by this formula, okay? Just tell me the age, I'll subtract the mean, divide by standard deviation, and that's your Z-score. If you're the customer, so, oh, hey, I'm 40 years old, what would my Z-score be? I'd plug in 40 for your score, take off the mean, divide by the standard deviation, that would be your Z-score. We can find the Z-score of any customer. And that's what I did here in this chart. In this chart, I found the Z-score for any of our customers. So if our customer was 40 years old, their Z-score was 1.58. What does that mean? They're just above average, but not much. They're still in that typical range. Just slightly above average is where I put them, all right? Because they're above a 1. So you're slightly above average, but nothing to raise a hair at. These are the ages. I know it looks really, right? It's 40, then it's 43, right? 2 years, right? Well, that happens. If you're 43, that raises a flag like, wow, that's interesting. That person bought my treadmill. Notice, with just the information from this descriptive box and some basic algebra skills, I get a very huge concept in business or in any field, the Z-score. Who are the outliers on my intelligence test? Who are the super smart? Above a 2? Above a 3? Oh, heck yeah. Who are the people that are dealing with, emotional IQ issues or intelligent issues or memory issues? Anybody in these numbers, okay? Anybody below a -2 is dealing with a memory issue. They're not recalling well. Below a -3, you're probably dealing with dementia issues. There's so much we can talk about once you know 2 numbers, the mean and the standard deviation. And of course, worry about outliers because it does affect. But utilizing the mean and standard deviation, we can build the Z-score chart. And from the Z-score chart, I can talk to you about a representative person on any test. In this case, the test would be age. A typical person in my store buying this treadmill is between 21 and 35. Anybody below 14 is an outlier. Anybody above a 42.99 is an outlier. Anybody below a 688 is an extreme outlier. Anybody above can't talk anymore. Anybody above a 50 is an extreme outlier. Sometimes extreme outliers don't make sense. I do not expect a 5-year-old or 6-year-old to buy a treadmill, okay? This could happen, and I'd wonder what brought them in and how can I change my marketing to them. If you're looking at a memory drug and you're wondering, wow, how did their memory happen? How did they memorize more? You'd ask, what was your tactics? Was it the memory drink that we gave you? What was your sleep? What was it that allowed you to memorize more than everybody else? These are the people we're interested in, right? In the red and the blue range are the people we're really interested in. In fact, anybody above a 50 we really are interested in. And anybody below a 6 we're really interested in. So again, one last time, hit me baby. If you have the mean and the standard deviation from the previous video, find them in the descriptive box. You can build the Z-chart. Again, the mean is the center of the Z-chart. Always. The mean is the center of the Z-chart. The standard deviation is your spread factor. It's your per person differential. And that's what I utilize here. I add and subtract 7.2. That's all I did. From the center, I add 7 each time, and I subtract 7 each time, 7.22 to be exact. And that's how I get this diagram. And from this diagram, woo, doggy, we can explain our customer base, our client base, our patient base pretty well. And we get to what everybody cares about, the outliers. Thank you guys for watching this video. Stay tuned for others.